Hello guys, let's today define new concept which is the extrema. I'll begin with the definition of extrema. Here, let function f be defined on interval. This means the function must be defined or continuous on this interval, containing the point c. We have f at x equals c, minimum value of the function on this closed interval I, if f at x equals c less than or equal f at x for all x in the interval. By another meaning, it means the smallest value of the function on this interval. Okay, here if the value of the function at x equals c is the maximum value of f on I, when this occurs, if f at x equals c greater than or equal fx for all x in the interval, it means greatest what? Greatest value. Okay, here we mean by the extrema the minimum value of the function, the maximum value of the function. The word extrema is a plural of extremum, or the extremum is a singular of extrema. Okay, we name the value, minimum value of the function, absolute minimum, because the function has no value less than the absolute minimum, okay, or less than this value, absolute minimum. Absolute maximum, it means that is the greatest value of the function. The function has no value greater than the absolute maximum. That is why we name it absolute maximum or absolute minimum. Here, let me show you here on the graph, as you see here, the function defined and continuous. It means defined or continuous at every value on the closed interval -1 and 2. Closed interval, as you see, defined here, defined everywhere, or the function is what? Continuous. In this case, we have the least value of the function, on this closed interval, we name it what? Absolute minimum, which is at the value what? Here, absolute minimum at what? At the value 0. That is from the graph. By looking at the graph, I can identify where the maximum value or minimum value. Here on this closed interval, the value of the function is the greatest value at x the point 2 and 5, the ordered pair 2 and 5. Absolute maximum at which coordinate the point at which we have absolute maximum. Okay, I write purification for minimum and maximum, but later I will write without purification. Okay, clear now the definition of maximum and minimum I can identify, but be careful, the function must be defined at the greatest value. Yeah, it means, yeah, if we have this if we have like this graph and at this point the function undefined or it is not continuous, it looks like at what? At this point c, and this value of the function fc, we can consider f at x equals c as minimum value. It looks like minimum value, but the function undefined or discontinuous at x equals c. Be careful, the function must be defined at the extrema, or at the extrema the function. Okay, clear? Now, here defined what the theorem, it is, we have to understand what is the meaning of this theorem. The extrema value theorem, if f is continuous, look, the definition, it is very important. Function f is continuous. Look here, continuous. It must be continuous. On a closed interval, not open interval. Every word we need something. Okay? Closed interval. It has a left end and they have a right end. Then the function f had both a minimum and maximum on the interval. Yani if we have a function continuous on a closed interval, so the function, it will have both minimum value and maximum value on this interval. Okay, now I'd like to define another concept. What is the meaning of relative? Not absolute, relative. Extrema. It means relative maximum or relative minimum. Miss, what is the difference between them? When we talk about the extrema, on a closed interval, we name it absolute maximum, absolute minimum. But here, if there is an open interval containing point C on which f at x equals C is a maximum, then we name it what? Relative maximum of the function f. Or you can say that it has a relative maximum at this coordinate here at the point C and f at C. At the point what? That is a coordinate, because to find the y coordinate of any x coordinate replaced in the original function. If there is an open interval containing C, open, that is why we say relative. Okay, so we name it. We name f at this point, f at x equals C is a minimum. Then this means we will name it relative minimum. It means if we have a minimum value on an open interval, we name it relative. Okay, minimum value, relative minimum. If it has maximum value on an open interval, we name it what? Relative maximum value. The plural of relative maximum is relative maxima. Okay, and the plural of relative minima is relative minima. Okay, the plural. This one, maximum, minimum. This one for singular. Okay, it's a plural, different. And we can name it the relative also local maximum or local minimum. Clear? Now, the last definition, it is very important. Be careful. When you read the definition, you have to understand the meaning of everything in this definition. Here, let f be defined. Look here, it is very important. What? Defined. At x equal what? C. So the function must be defined at this value. If the derivative at the value of x equals C such that the function defined at it equals 0 or not differentiable at x equal what? C. The function is defined at it or it is in its domain. Then C is a critical number of the function f. So what is the meaning of the critical number? We mean by the critical number the values of x in the domain of the function, or by another way, the function defined at it, the function continuous at it. Okay? Such that the derivative of the function does not exist or equal what? 0. That is from the definition. Okay? Or by another way, to find the critical number or the values of x at which the function does not exist or equal 0, find the derivative first, then find the values of x at which function the derivative equals 0 or does not exist. In this case, from the graph, I can identify by easy way what is the critical number from the graph. Okay? If I don't have the rule of the function, and from the graph, how to identify. Okay, here I'll search for the value of x at which the function has a corner, like this one. It has what corner? and the function defined at it, continuous at it, as you see. The value of x here, it will be a critical number. Also, if we have a sharp point of the function, sharp point, take the value of x at this point, which I name it, for example, a, is critical. The value of x such that the function defined at it, okay, we have a sharp point, have a cusp or break, okay, like this one. It has what? Critical number. These three cases, or maybe, okay, which has what? Critical number such that the derivative does not exist at it. Okay? Another case, if we have a horizontal tangent, the curve like this one, okay, it has a horizontal tangent, so at this horizontal tangent, the value of x is what? A critical number. The most important thing that you have to know about the critical number, it must be in the domain of the function to be critical from the definition. These guidelines I will show you when I find the absolute extrema on closed interval. But now, let's solve these exercises. Find the value of the derivative if it exists at each given extremum. Okay? Extremum, it means what? Maximum or minimum, relative. Okay? Here, you have to know, at the extrema, please, I'd like to remind you by something before I solve this one. For this, no, later, okay, no, later I'll tell you this one. Here, the extremum here, which has horizontal tangent, corner, sharp point. Here, it has what? Horizontal what? Tangent. It has a horizontal tangent, as you see here. He asked about the derivative. It means the derivative at the extreme, it will be what? 0 or does not exist. 0 or does not exist. Horizontal tangent, here the derivative occur at this point, given point 0 and 0, it will be what? The derivative at this one equal 0. Okay, at this critical number, x equal 0. Here, as you see here, I have relative maximum, relative minimum. Why? Because what this function defined on open interval. Open interval. It is not a closed interval. I can't say absolute. Okay? In this case, as you see, it has a horizontal tangent, so the derivative, okay, at 0, it will be what? 0. The derivative at 2, it will be what? Also 0. Clear or not clear? Okay. Now, I'll continue to solve number 3 with you. Here, it's so clear, this one. It has a horizontal tangent, so the derivative, this function is called g, the derivative of the function g at critical number 2, as you see, it will be what? 0. Okay, 0. Here we have also horizontal tangent. Here, f, the derivative of the function at negative 2 over 3, it equals what? 0, because it is a horizontal tangent. Okay. I think it's clear now. Now, let's solve this one. It's so clear the critical number here occurs at what? Negative 2. But it has a corner. The derivative of the function at negative 2, it will be what? At this extrema, because the extrema occur at the corner sharp point. But be careful, it must be defined at it. The function defined at it. Here does not exist. Here the derivative here what? It has, because the derivative from left, not like the derivative from right. The derivative at the extrema here 0, it will be does not exist. I think it's clear. Okay. Here, in exercise 7 to 10, approximate the critical numbers of the function shown in the graph. Determine whether the function has relative maximum, relative minimum, an absolute maximum, an absolute minimum, or none of these. It means has no extrema at this critical number, or none of these at each critical number on the interval shown. This example, which I'd like to remind you by something before we will solve it, okay? Here, I have to remind you by what? I have to remind you by the critical number at which the function must be defined at it. That is the first step, okay? And any critical number will be extrema if the behavior of the function change from increase to decrease or decrease to increase. But if the behavior of the function does not change, so the function has no extrema at this critical number. By another way, I'll show you here in this one, if we have a function like this one, okay? Here a critical number because it has a horizontal tangent. The behavior of the function before this critical number is decreasing. The behavior of the function after this critical number is increasing. Since the behavior of the function change from decrease to increase, we will consider the function at this point at what? 1 and f1, okay? Extrema. Relative minimum. Relative minimum. I think it's clear now. At any critical number, we have extrema if the behavior of the function change. Okay, that is what? Relative what? Minimum. It's so clear. The function decrease until it reaches to the least value, then become to increase again. Here, if we have at this value, for example, okay, at this point it is not undefined, defined. Okay, at this critical number, since the graph has a horizontal tangent, here at the critical number x equal a, the function before it, the behavior of it increasing, and after x equal a, the behavior of the function is decreased. In this case, the behavior of the function change from case to another case. We will name it what? So clear, increase until to reach to the greatest value, which we will name it relative maximum. Okay, here relative minimum. Okay, minimum. Clear? Maximum. Okay. But sometimes, as I'll show you here, look like this one. Here that is the derivative equal what? 0. The behavior of the function here what? Increase. And here what? Decrease. Since the behavior of that does not change, here increase and increase, in this case, we name at this value f equal what? I'll name it, for example, c, at x equals c, the function has no extrema. Has no extrema. Clear? If the behavior does not change, increase, increase, decrease, decrease, so has no extrema. Like this one. Look here. At this point, the derivative 0. Here, what? The function here decrease, and here what? Decrease. So in this case, it is no extrema at this. There is no extrema at this critical number. It's clear now? Not at each critical number we have extrema, such that the behavior of the function is change. Clear? Now, let's solve number 7, number 8, 9, but in hurry because I already explained in the live session. Okay, in the live session. Here, where is the critical number? I know some of you participate and tell me at the point what? X equal to is a critical number. He asked me to determine the critical number, that is the first request. The second one, tell me we have relative minimum or relative maximum, okay, or absolute or none of these. Okay, at the point, the critical number here, he asked me to identify. Critical number, x equal what? 2. That is the first request. Second request, around this point, the behavior of the function change. Increase, decrease, so we have what? Increase until reach to what? The greatest value, then become 2 degrees again. This case, but be careful again. Another note. Any absolute extrema, it will be relative. Any absolute extrema, it will be relative. Okay, but not every relative will be absolute. In this case, we have a relative because we are talking about what? Open interval. But it is also greatest to what? Since if it is the greatest one, okay, if it is the greatest value, in this case, we name it what? Absolute. يبقى here, at x equal 2, okay, the critical number x equal to, the function, and all at x, function has what? Has relative maximum or absolute also, absolute a maximum. Since it is relative, I will say, sorry, if it is absolute, in this case, since it is relative maximum and it is the greatest value, I said absolute what? Maximum. خلاص? Clear? Clear or not clear? Here, because it is the greatest, this function has no greater than this value of the function at f2, so in this case the function has absolute maximum, the greatest, and also relative because the behavior of the function changes from increase to decrease. Okay, clear. Now for number 8, how to solve it? Where is the critical number? Here at 0 it has a horizontal, at 0 it has a horizontal tangent and it is the function defined at it, as you see. Here the critical number what? Critical number x equal what? 0. That is for number 8. But the behavior of the function before increase. The behavior here what? Increase. As x increase, the y increase. As x increase, y increase. It means as x goes to right, the function goes up. As x goes to right, the function goes up. So that is why we said the function is what? Increasing. So in this case, the function has no extrema, at x equal 0, which is the critical number.